So let's prove a particular language is not regular by using pumping lemma. So the given language is a power n b power n such that n greater than or equal to 1. So your language is equal number of a's and b's. That is n number of a's followed by n number of b's. Okay, so minimum condition n become 1 means a power 1 b power 1. Then a square b square, a cube b cube, etc. This is an infinite language, right? So how to solve this particular problem? So the first step is assume L is regular. So we are assuming that this particular language is a regular language. Then finally we will prove it is not regular. Contradiction. Okay. So we are taking pumping length. Suppose I am taking n is equal to 7 and 7 states. Okay. Let pumping length n equal to 7. I am taking 7 as the pumping length. Okay. Then, so I am next step is we are going to take any particular string w belongs to our language. Any string you can take. What is the condition? The length of the string should be greater than or equal to pumping length 7. Okay. So we need to take a string of length 7 or more. Okay. So this is 6 length. So next I am taking 4a, 4b. 1, 2, 3, 4, 4a and 4b. Okay, this is a w. So the mode w is equal to 8 here, which is greater than or equal to 7. Right? Now I am taking some cases here. I am taking case 1. Case 1 I am taking so if the length of the string is greater than or equal to n, then we can divide w into 3 parts, x, y, z. Okay, so I am dividing w, I am dividing the string into 3 parts. That is our fourth step. So here I am taking the y part in a. Okay, I will get a y from a. So what is our w here? A, b, 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 b. Okay, so I am taking x, these two x, and these two as y, and these 3 as z. I am taking, just I am showing you the 3 cases only. You can take any case and you can prove it is not regular. So for the first problem I am just showing all the cases. So I am taking y part, y in a part only. Okay, so this is x, this is y, this is z. So what is our condition? Y should not be 0, y should be greater than 0. What is the length of y here? 2, right? 2 is greater than 0. So second condition is okay, and length of x, y should be less than or equal to n. That is the third condition. What is the length of x and y? 2 plus 2. Length of x is 2, length of y equal to 2. 4 is less than or equal to pumping length 7. This is also true. Okay, then we need to prove x, y power I z belongs to our language. Okay, so if I am taking I equal to 1 means, if I am taking I equal to 1, x, y power 1 z equal to same thing, a, 4b, 1y. Okay, if I become 2 means y 2 times, y power z, a, this is our y, right? So 2 times means a. Okay, then b. So what is the length of how many a's here? Here the number of a is equal to 6, number of b is equal to 4. Okay, according to our problem, there will be n number of a's and n number of b's. Here it is a power 6, b power 4. Okay, so this is not belongs to our language. So we can say therefore L is not regular. Okay, if I am taking y part in b, if I am taking y in b part, so our string is a, b, 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 b. Okay, so this is my x, this is my y, this is my z. Okay, so what is the length of x? 4, 1, 2, 3, 4. This is x. Okay, length of y equal to 2, length of z equal to 2. So what are our conditions? Length of y should be greater than 0. Length of y is 2, which is greater than 0. So this condition is okay. Length of xy should be less than or equal to n. Length of x is 4. Length of y equal to 2, 4 plus 2, 6 is less than or equal to 7. This is also true. Okay, we need to check whether x, y power I z belongs to L or not. Okay, this we need to check. So when I am putting I equal to 1, x, y power 1 z equal to, this is our x, right? This is our y. Y power 1 means same thing. BB, and this is our z. When I equal to 2, x y square z means a. This is 2 times y, right? So it become 4 y square. Okay, then 2b. See here, number of a is equal to 4, number of b equal to 6. That is a power 4, b power 6. This is not belongs to our language. So we can say L is not regular. Second case also we proved. You don't need to prove all the cases. For the first problem only I am just explaining you all the cases. I am taking the third case. Y in both A and B part. Okay, so our string is A, B, 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 B. So I am taking this as x, I am taking this as y, I am taking this as z. So length of x equal to 3, length of y is equal to 2, this is y, AB. I am taking y in A and B part. Length of z equal to 3. Okay, so what is the length here? Length of y is greater than 0, condition is true. Length of xy is equal to 5, which is less than or equal to n, that is 5 is less than or equal to n is 7. This is also true. Next I want to prove whether x, y, z belongs to L or not. Okay, when I equal to 2, x, what is x here? Triple A. Y is AB, AB, AB. Okay, then z is y square. Okay, B, B, B. Here length of x equal to 5, length of b is length of a equal to 5, length of b equal to 5. A power 5, b power 5, equal number of a's. But here see, n number of a's, then n number of b's. Here you can see 4a, a power 4. Then you can see a single b. Then you can see a single a. Then you can see a b power 4. So this is not in the format a power n, b power n. That is n number of a's, then n number of b's. Here you can see 4a, then a single b, then a single a, then a 4b. So this is not in this format. So this is not belongs to our language. So we can say L is not a regular language. Okay, so initially we assumed that L is regular, and finally we proved that L is not regular using pumping lemma. Understood?